I'm going to demonstrate how to perform a simple linear regression. And what I mean by simple linear regression is that we are going to use one quantitative predictor variable to predict the score on one quantitative outcome variable. So one of the assumptions here, or a couple of the assumptions actually, is that the relationship between these two variables will be linear. And in other words, as the value of one variable continues to increase, the value of the other variable will continue to increase in a similar pattern without showing a plateau or a curvilinear relationship. We could also have the negative effect, whereas the value of one variable climbs, the value of the other variable will decrease. And again, it shows that same linear pattern. One of the other major assumptions for this particular analysis is that both variables need to be quantitative and normally distributed. So we need to screen for those things as part of our initial screening process to make sure both variables are normally distributed in order for this to work. And then lastly, we want to make sure there's at least a moderate level of a correlation between these two variables because one variable cannot predict the other unless there is a correlation or a relationship there. So we're typically going to do this analysis when we have variables that we've already established are at least moderately correlated with one another, and then we can use the score on one to predict the score on the other. There are other types of regression analyses that are more complex, but this is the simplest form of regression in which we use one variable to predict another. So we're going to use this data here, and so what we have, we're going to use two variables here. One is called develop, and that is a measurement of emotional development or emotional maturity, and the higher the score, the more emotionally developed somebody is. And then we're going to see if that can predict someone's social interactions. In other words, the quality of their social interactions, with again, the higher the score on this particular scale, the more capable they are of having productive and healthy social interactions. So we want to see if emotional development can predict someone's ability to have good social interactions and social relationships. So we've already established that these two are at least somewhat related to one another, but now we want to develop this regression model so that if we know someone's emotional development score, we can then predict what their social interaction score will be. And so we're going to develop a regression equation to do this. And we can also develop a scatter plot to go with this so we can visualize this relationship. And so we're going to develop a formula that can help us, if we know the development score, we can plug that into a formula with a couple of constants, one being the slope of the regression line and the other being the y-intercept of that regression line. So we can plug in that development score and then it will give us a predicted social interaction score. So in order to do this, we want to, first of all, go to the analyses menu, and we're going to find the menu for regressions and choose linear regression. So the first thing we want to do is enter in our dependent variable, which in this case is going to be the social interaction score. Click confirm, and then our independent variable is going to be that emotional development score. Now, oftentimes when we do these kinds of regression models, there's an order to how these variables occur, and that's how we decide if one is the independent variable and which one is the dependent variable. So in this case, we want to see if having a certain emotional developmental level will then predict social interaction. Now, you could do the opposite. You could have social interaction be your independent variable in order to predict emotional development. So a lot of times those can be interchangeable, but we want to identify what we think needs to happen first to then explain what the outcome might be. And in this case, that's what we want to try and do. We want to try and explain social interaction by examining emotional development. So it's important then to be able to identify those variables if we feel we want to examine them being in a temporal order. One has to occur in order to explain the other. So once we've entered these two variables in, we can go ahead and click calculate. And so we're going to go directly to our raw output here, and so we can examine the important elements of this. So the two of the values, the two most important values for us right here, are in this first table in this column that's labeled unstandardized beta. And so the two values in this column are the two values that are going to go into our regression model or regression equation as the constants. And the first row is the y-intercept value of 2.757. The second, which is labeled the same as our independent variable or our predictor variable, develop. That's the slope of that line, so 0.676. So those two values will go into our regression equation, which we'll talk about here in a minute when we develop our scatter plot. The other thing we can look at are these model fit statistics. And what the model fit statistics will tell us is if our model is statistically significant. So the p-value listed here, if this p-value is less than 0.05, we can say that our model is statistically significant. In other words, it can predict the outcome variable better than chance. So it can consistently pick a realistic and pretty accurate prediction better than just chance. So that's what we like to see. We like to see a statistically significant model, which means our model will do a good job of making a prediction, at least better than chance. The other thing we want to look at is this r-squared value, which is essentially, we're going to look at this r-squared value, which is essentially the r value, the correlation between these two variables. We take that r value and we square it. And so in this case, the r value squared for this relationship gives us an r-squared value of 0.48. Now, how we interpret this is the r-squared represents the percentage of the variance in the outcome that's predicted by our predictor, or can be explained by our predictor. So how much variance in social interaction can be explained by emotional development? Well, in this case, about 48% of the variance in someone's social interaction score can be explained by that emotional development score. The larger this number, the more clinical significance there is in our regression equation. So this is a measure of effect size, essentially. And so the larger this value, the more clinically relevant this prediction model is. And so when we get to that 50% level or beyond, then that's considered to be a clinically significant model. So if we can have one variable explain 50% or more of the variance in the outcome, that's considered to be a clinically significant model. So at this point, we can conclude that we do have a statistically significant regression model, and that regression model has an r-squared value of 48%. In other words, the predictor can explain about 48% of the variance in the outcome. And so we definitely want to report these two unstandardized beta values, the slope and the y-intercept. We can also report the 95% confidence interval for these two values. And then we also want to report the f value and the p value for the model fit statistic, and we also want to report this r-squared value. So let's now see how we can visualize this relationship using a scatter plot. So we want to go up to the plots menu, and we want to choose scatter plot. So go to our plots menu, we want to select the scatter plot visualization, so we want to click on that. We want to enter in our x variable, which is our predictor variable. In this case, it's develop, emotional development, and then our y variable is the outcome, and we know that that is the social interaction variable. So the x variable is going to be along the bottom of our scatter plot, and the y variable, or the horizontal axis, and the y variable is going to be that vertical axis. And so now the scatter plot will be developed, and so we can see the actual dots, the actual values for each participant. Now we can also have Intellectus create the regression line for us using the equation we just developed. So we want to enable regression lines to be here, and then we can actually see that and how that would work in reality. So once we've made those selections, we go ahead and click Submit. And you can see here, here's our scatter plot with all of our individual data points lined up for each individual, what their development score is, matched up with what their social score is. And then here's that regression line, or that line of best fit, that we then use to make predictions. And so one of the nice things that's produced here is our actual regression equation, where it says regression line here. So again, here's that slope value that we had in our previous output, 0.68, and here's that y-intercept value. So if we know x, which is the development score, so let's say someone had a development score of 10, we would plug that into the formula, do the calculation, and so if we kind of follow this, so a score of 10 would then predict our social development score. So that's essentially what the regression line is going to do. Now, these predictions aren't going to be perfect. The larger the sample we can get, the more likely it is that we're going to have more accurate predictions. But the stronger this R value between our two variables, in this case 0.69, and the larger the R squared value, the more accurate these predictions are going to be. And so that's why that R squared value is a measure of effect size. And it also gives us an indication of how accurate our predictions will be, indicating that we've got about 48% shared variance between our two variables. And so that's considered to be a pretty strong predictor. So what we've learned here is how to do this simple linear regression, how to create the values that will go in a regression formula, and then we've also learned how to develop a scatter plot so that we can visualize this regression line. So hopefully you've learned something from this video, and good luck using this in your own research.